Very important chapter. Here, if there is any change in the linkage of magnetic lines of force in a coil, then a current is produced in the coil, and that current is called induced current. In short, if there is a coil and if there is a magnet, and if there is a relative motion between the magnet and the coil. Relative motion means the magnet is stationary, coil is driven inside the magnet and taken out from the magnet, or the coil is stationary and magnet is driven inside the coil and magnet is taken out from the coil. This way we can actually we are changing the linkage of magnetic lines of force with the coil. What do you mean by linkage of magnetic lines of force? Linkage of magnetic lines of force means if, for example, for a certain period of time, if there are 100 magnetic lines of force passes through a coil, and after some time it becomes 90 and then 80 and then 70. This is called the change in a linkage of magnetic lines of force in a coil. Now we can do it experimentally. I can show you here with an example. Here is a coil and here is a galvanometer. Galvanometer is a device which detects the existence of current, which detects the presence of current. And you can see here, the moment I will put this magnet inside the coil, there is a deflection in the pointer of the galvanometer. You can see here the pointer is deflecting. The pointer is deflecting the moment I put inside the magnet inside the coil. If I don't, if the magnet is stationary, there will be no current, and the moment I bring it out from the coil, again there will be a deflection. So whenever there is a change, you can see here, whenever there is a change, only current is produced. You can see here current is produced, and that is shown by this galvanometer. And if I stop this movement of magnet, no current will be produced. Even if I oscillate this magnet outside the coil, even then you can see that current is produced. Now here coil is stationary and magnet is moving, and now I will do just other thing. I will make the magnet stationary and I will move the coil. I will move the coil. Okay, so even then we will see that when magnet is stationary and the coil is moved inside the magnet and then taken out from the magnet, then we can see that electric current is produced in the galvanometer. Okay, so let's see how it works. The main thing is that there should be the change in linkage of magnetic lines of force. Now you can see that magnet is stationary and coil is taken out and taken in, and you can see that galvanometer is showing the deflection. Okay, so if there is a change in linkage, even the magnet is stationary and coil is taken in and taken out, the story is same. That magnetic lines of force, the linkage of magnetic lines of force or the count of magnetic lines of force changing here. Even the coil is stationary and magnet is inserted into the coil and then taken out, even then we are doing the same thing. The linkage of magnetic lines of force, that is going to be changed every moment, and as long as there is change in magnetic lines of force inside a coil or associated with the coil, then we will see that induced current is produced. And the moment the magnet is stationary or the coil are stationary, both are stationary, then we can see that there is no production of induced current, because when the magnet is stationary, the count of magnetic lines of force does not going to be changed. If the magnet is stationary, see you can hear, there is no change. If it is 100 lines of force passing through the coil, it is after some time it is again 100. But if we move it, so it becomes sometime 100, from 100 to it becomes 110, 120, then it again may reduce from 120 to 110, then again 100, then again 90, then again 80. If this count of magnetic lines of force changes with the coil, only then we can find that there is a production of induced current. Okay, so this much only for today's electromagnetic induction. So this is the introduction of the electromagnetic induction, and in next class we will learn Fleming's right hand rule and thereafter generator.